guys, this is the second to last section in this chapter. It's section 13.7 called Descriptive Statistics. And now we're starting to get into why we really even care about statistics and what we're going to be doing next week. Okay, so statistics is just a way to present information for it to be a little bit more meaningful. You can say somebody did, like the example they use, I think, no, it's not for this one, sorry. I can say Tom did really well on his SAT, but what does that mean? Well, if I tell you this was the average and only 95% of the people, only 5% of the people did more than 10 points better than the average and Tom was in that, it means a little bit more, right? So that's what descriptive statistics do. It gives you information, but it gives you specifics about the information so you know how valid it is, how significant it is, okay? So we're going to go through a couple of definitions first. You should have seen most of these numbers. And then I think we're going to do a little bit of calculations with it, but then next week we're going to do a little bit more calculations with it, which is really learning how to figure out whether your information is valid or not valid, okay? Not valid, whether it's useful, whether it's meaningful, whether it's significant is a big word we use in statistics, okay? So if you go to page 554, right there you have a set of 5 definitions, okay? Mean. You guys, if you haven't heard the word mean, you've for sure heard the word average, and you know what the average is, right? It's, what's the average? It's the average. You add everything up and you divide it by a total. So the mathematical definition of it is average is the sum of all your n's. Is that how they write it? Nope, of all your x's, sorry. Divided by n. So what are all your x's? Well, something we use a lot in class is grades. So how do I calculate an average? I add up everybody's grades and I divide it by how many grades I had. So in statistics, for example, I'd be dividing it by 5. And if I have, let's say 405 is my average, is my total, I added up everybody's grades and they added up to 405. And Miss Wright says, what was the average on that test? I'm curious how everybody did. Well, I'll figure it out, right? And I'll say 405 is 81 is my average, okay? So it's just a way to, instead of saying, well, Shannon and I got this and Bradley got this, I can say, well, I had a B average. And it's a lot easier to convey the information that way. Now, there's another term that sometimes gets confused with that, which is the median. And sometimes the median and the average are the same, but that doesn't happen that often. The median is actually the middle point. So if we're going to grades again, let's say these are my grades. Now, when you're figuring out your your mean, which is your average, you just add everything together. It doesn't matter what you put first and second. When you're trying to figure out your median, you have to make sure you write everything in order, either ascending or descending, it shouldn't matter. And you go to the middle. So cross out the two ends, the two inside, that's my median. Okay, what happens if I actually had one more grade? So what happens if I also had a 94 here? How would I calculate my median? Well, I'd still cross out the first two, second two, but now I have both of these guys left. So how do I figure out the median? I take the average of both of those. Okay, so if it's an odd number of, if there's an odd number in your sample, your median is just going to be the number in the middle when they're written in order. If there's an even number, you're going to have to average the two numbers in the middle. Mode. Okay, when you have a data set that's this tiny, you're not often going to have a mode. But a mode reminds me of the Spanish word moda, which means fashion. So when something's in fashion, there's lots of it. That's what a mode is. A mode is something that you have lots of. So whatever value appears the most. So if I was doing grades for all of math in the whole school, for example, possibly there would be a mode, right? It's possible that for 7 kids I still have a mode, but in order to have a mode, at least one value has to appear more than once. So let's change this data set a little bit. Let's add some numbers to it. Okay, now the easiest way to do this is still to write them in order so that you can make sure that you account for every number. these are small enough that we're gonna say, yeah, this is our mode right here, 94, because it appears 3 times. And your median and your average are usually gonna be kind of close together. Your mode could be anywhere on there, because your average could be a 70, and you got a bunch of numbers that were low, but you happen to have 3 95s, or your average could be a 90, and you had a bunch of high numbers, but you happen to have a few 70s or something, okay? So your mode is not necessarily close to your mean or your median. Your mean and your median are usually close together. They're not gonna be the same number that often, and sometimes they may not be that close together. But for the most part, mean and median should be close. Mode is just kind of whatever. Another term, mid-range, which is the average of the highest and the lowest score. So again, we're gonna use the test example. Let's say that's it. Now I'm not taking the average of the whole thing. I'm gonna find my lowest score and my highest score, and I'm gonna average the two of them. So how do you do that? You add them together, and you divide by 2. Which is funny that it happens to be 81, because I think that was our average earlier, right? So 81 would be the mid-range for that. Mid-range will probably be kind of in the ballpark of the mean and the median. And then your last one is your range. What is your range? Your range is, think about it when we were doing graphs, and what was your range? It was everything in the y-axis. It's similar. Your range is basically what your values span. So if you were plotting these, it kind of would be everything on, except it would be on your x-axis, not your x-axis, not y-axis. But think about the term range, and for graphing, it's all your y values. For this, it's all your numbers. So your range is, these are all the numbers you have. So if you were gonna plot them, what would your range be? It would be 67 to 95, right? And if you wanted to give a more specific range, you'd go ahead and subtract them. So the range would be 95 minus 67, which would be 28. So if Miss Wright came to me with this and said, I want to know your mean, median, mode, mid-range, and range for your test. Well, we already figured out what the mid-range is. To figure out the median, we'd line them up in order. 67, 69, 75 would be our median. So I'd say, okay, my mid-range is 81, my median is 75, my mean is whatever it's gonna be, and then I'd say, and my range is 28. So she knows that the difference between the highest grade and the lowest grade was 28 points, okay? So that's the definition for all of them. Again, they're in the book. And really what we're gonna do, we're gonna go through a couple more things, because this is just kind of giving you an idea of where the data falls. What's my lowest number? What's my highest number? Kind of where are they centered? So it just gives you kind of a general idea of your information. Then we're going to go over some other statistics, well, some other numbers, which are really the meat of statistics. But let's do examples 1 and, just example 1. And then we'll go into some more numbers, okay? So, example 1 says, find the mean, median, mode, mid-range, and range. So everything we just went over. For the student scores on a 10-point quiz, okay? They're listed here not in order. I'm gonna go ahead and write them down in order because it'll help us with some of our numbers. So my lowest number is 5, 6, 6, 7, 8, and then I have 1, 2, 3, 4 9s and a 10. That's 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers. Let's make sure I wrote down 10 numbers. 6, 7, 8, 9, 10. All right, so those are all our numbers. What's the first thing we're going to find? The mean. That's the average. So 5 plus 6 is 11, plus 6 is 17, plus 7 is 24, plus 8 is 32, 41, 50, 59, 68, 78. So our mean is just going to be 78 divided by 10, which is 7.8. Let's see if that's what they got. If they didn't, it's just because my math was wrong. 7.8. All right. How do we calculate median? Remember, we just go to the middle. So we take 1, 1, 2, 2, 3, 3, 4, 4. Our median is going to be right there, between two numbers. So what do? We take the average of those two numbers. This is easy. The average of 8 and 9 is just 8.5, right? So that is our median. What about our mode? Remember, the mode is the thing that's in fashion, the one that comes out a lot. Well, that one's kind of easy to see once you line them up, right? 9 is our mode. Mid-range. What was mid-range? The average of the first and last number. So 10 plus 5, 15. 15 divided by 2, 7.5. So that's going to be our mid-range. And it's pretty close to our mean, right? And then our last thing is our range. So what's our range? It's the difference between the highest and the lowest number. Our scores go from 5 to 10. So what's the difference between 10 and 5? 5. That's your range. That's it, right? Those are pretty easy calculations. So we went over mean, we went over median. In the book it kind of describes all these terms in relation to each other. But what we measured, all of these, so the mean, the median, the mode, and the mid-range are all measures of central tendency. So what does that mean? It just kind of tells, central is middle, average, median. So it just kind of tells you where your numbers sit. Okay, what the average of them is and kind of where they're spread out. So it just gives you an idea. Okay, my scores averaged around 7.8. They were between 5 and 10. Okay, you can kind of visualize that. But that's not statistics, right? What does statistics get to? We want to look at deviations measures, which are the terms that are on the bottom of page 555. We have mean deviation, variance, and standard deviations. Okay? Now, deviations measure how far a particular score is from the mean. So, I already know what my mean is, I know all that, but I want to know, okay, how good did you have to be to get a 10 on this quiz? And this is just a quiz, right? But this, I think the big example they give here, I think it's on the next section though, is they look at SAT scores. Standardized tests are all about deviations. They don't want to know what your score was, doesn't matter as much as how well you did. How hard was it to get the score that you got? Okay, and that is what these standard deviations look at. Because you can get a 1400 on your SAT this year, and you can get a 1400 on your SAT next year, but this year you could be in the 99th percentile, and next year you could be in the 97th, because it depends on how everybody else did. Just like when I give you guys tests, I always curve it so that somebody got 100. The SAT doesn't do that, but they do look at your percentages, because what if you got a 1400 this year, but nobody got above a 1400? And then next year you got a 1400, but a bunch of people got 1500s or 1600s. Okay, so the measures of deviations is how one particular number looks in comparison to all the other numbers. And that's really what we're going to be looking at when we do statistics. So, what are the three calculations that are going to tell us that number? The first one is the mean deviation. And it's the mean of the absolute values of the deviations. So what does that mean? Remember, we have sigma, which means the sum of. I think I've told you guys that before. We're going to be seeing that a lot in statistics. And do they do X? Nope, other way around. Okay, so this is how you calculate it. What does that mean? So for each value, you're going to take your value, you're going to subtract the average from it, and you're going to do that for all the values. So you're going to add them all up together. In our last one, it was 10. And then you're going to divide by how many values you had. Okay, so for our last test, what was our mean? We decided was 7.8. So I would do 10 minus 7.8, 9 minus 7.8, 9 minus 7.8, because there was 4 of them. Okay, I do it for all of them. Now sometimes, for example, if I do 5 minus 7.8, I'm going to get a negative number. And if I actually calculated the mean, when you add everything up, you're going to end up with 0. So that's why you have to do absolute values, because you only want to know how far away a number was from the mean. You don't care whether it was higher or lower, you just want to know how far away it was. And then n is your total number, okay? You'll practice these a lot and they'll make more sense. So that's your mean deviation. Then your variance, we use the letter s squared, which makes no sense, but it will in a little bit, is the squares of the deviations. So, again, you're adding up how far away stuff is from the average, right? So your number minus the average, every time you square it. Why do you square it? Because you make it positive, right? That's why we did the absolute value. Anything squared is positive. If you didn't square it, you'd end up with 0, just like you would with your mean deviation, okay? So, mean deviation, and honestly, I don't know that we ever use that. This is variance. Why does variance have the letter S squared? Why is that the symbol for variance? Because the symbol for standard deviation, that's a terrible E, is S, and standard deviation is basically the square root of this, right? The square root of S squared is S, so standard deviation. So why do you do that? Why do you square something and take the standard deviation? You have to square it to make sure it's positive. But you get a fairly big number. Most of the time what you look at in statistics, this is the big number statisticians are going to ask you. They're going to ask you, first of all, what was your N? So how many were in your sample? And the next thing they're going to ask you was, what was your standard deviation? Because if you have a huge standard deviation, your numbers don't mean as much. You want to have some relatively small standard deviations. Okay, so those are the things that are going to determine how varied our data was, how far all our points were from the average. The mean deviation, which I don't think we use, the variance, and really we only calculate the variance. So we can calculate the standard deviation, which is the big number that we like in statistics. Well, not big, we want it to be small, but it's the important number in statistics, okay? Example 2. They want you to calculate the measures of variability using the data from example 1, okay? So they want to know what the mean is, what the deviation is, what the absolute deviation is, and what the square deviation is. So if you look at it, we're not going to go through all this because it's a lot of math. So they calculated the average, the mean, the median, the mode, all that from example 1, right? And then they calculated the deviation. What's the deviation for 10? 10 minus 7.8. What's the deviation for 5? 5 minus 7.8. Notice the top numbers are positive, the bottom numbers are negative. If you look at the bottom, they do the sum. Look what it adds up to. 0. That's why we have to do absolute values and square stuff. Otherwise, we're going to get 0 every time, and how useful is that? Okay? Then they do absolute deviation. So what's that? It's the exact same numbers that are in deviation, except they take the absolute value of it. Square of deviation. What's the square of the deviation? You just take all the numbers in the column and square them. So how are you going to figure out mean deviation, variance, and standard deviation? Well, mean deviation is the sum of all the deviations, which they do in the 1, 2, 3, 4th column. Under absolute deviation, 14.4. That's the sum of all your deviations. What do you have to divide it by? N. What was N? There was 10. So 14.4 divided by 10, easy enough, right? It's 1.44. And if you look in the book, bottom third or so on page 556, they tell you. How do we calculate variance? Well, we have the sum of all the deviations, but we have to square the deviations before we sum them. On that table, notice they already squared the deviations for you. What's the sum of the square deviations? It's right there at the bottom, 25.6. Now we're dividing by n minus 1. So we're going to divide by 9, not by 10. My calculator's on my phone, which is how I'm recording this lecture. You guys can do it on your calculator, but I'm just going to trust the book. 25.6 divided by 9 is going to be, the book says 2.84. So that's our variance. But now we get our value that we really are looking for, our standard deviation. How do we calculate that? We just take the square root. Square root of 2.84, which you can do on your calculator. It happens to be 1.69. So for this data, we have an average of 7.8 with a standard deviation of 1.69. That is how numbers are going to be written when we start doing statistics. You're going to write your mean plus or minus whatever your standard deviation is. Those are the two big numbers we're going to be looking at, okay? So, homework. We're going to do exercise A and B, all the problems. So, all the way from 1 to 22. And it's just looking at numbers, looking at statistics, starting to understand what the meaning behind all of this is, okay? Now, next week, we're going to do standard normal distribution, which is just playing with this a little bit more. And again, it's just getting us ready to be able to actually find our own numbers and do statistics on them to see how meaningful these numbers are.